All right, let's jump right into this. Welcome to today's Explainer, where we're going to explore one of the absolute most mind-bending mysteries in our entire universe. We often picture our Milky Way galaxy just floating peacefully in the quiet dark of space. But in reality, we are on a high-speed cosmic roller coaster. We're being dragged across the universe by gravitational forces so immense, they are literally almost beyond human comprehension. So today, we're going to unpack the architecture of the cosmos itself, to understand the ultimate gravitational giant pulling on our galactic home. So to get us started, I want you to consider this absolutely wild fact. Right at this very moment, our Milky Way, along with our entire local group of galaxies, is hurtling through space at a staggering 631 kilometers per second relative to the cosmic microwave background. Just think about that speed for a second. But what unseen force could possibly possess the gravitational muscle to pull entire groups of galaxies at such an incredible velocity? Well, for decades, this was a massive puzzle for astronomers. For a really long time, scientists thought a region they dubbed the Great Attractor was the main culprit pulling us. But as our X-ray and infrared telescopes got better and peered deeper through the obscuring dust of our own Milky Way, they realized the Great Attractor was actually, scratch that, it was just a stepping stone. The true heavyweight champion is much further away, generating a massive gravitational basin. We call it the Shapley Supercluster. And get this, it's not acting alone. We are actually being simultaneously pushed by a vast, incredibly empty region called the dipole repeller. And together, they create this massive cosmic flow. And this whole realization, it basically forces us to rewrite the final lines of our cosmic address. You already know the start, right? Earth, solar system, Milky Way, the local group, and then the Virgo supercluster. And recently, scientists defined an even larger structure called Laniakea, which we honestly thought was our ultimate home basin. But cutting-edge data from the Cosmic Flows 4 dataset has thrown a complete wrench into that idea. It turns out, even our massive Laniakea supercluster might just be a subbasin, kind of like a smaller tributary in a river, being inevitably dragged into the 1,000 million light-year-wide Shapley Basin of Attraction. To really wrap our heads around this, we need to talk about what a basin of attraction actually is. The overarching structure of our universe is often called the cosmic web. I want you to imagine a gigantic 3D spider web where galaxies are strung along glowing threads, and where those threads intersect, you get these massive knots. The basins of attraction are the regions surrounding these knots where gravity absolutely dominates. They're basically deep gravitational wells that dictate the flow and motion of all matter within them, drawing everything inwards along those cosmic filaments. Section 1. Discovering the Shapley Supercluster. So how exactly did we stumble upon this monumental structure hiding in the dark? It is a fascinating historical detective story that spans over half a century. It started way back in the 1930s. An American astronomer named Harlow Shapley was down in South Africa, painstakingly studying photographic plates of the southern sky. He mapped an astounding 76,000 bright galaxies and noticed this highly elongated cloud of galaxies in the constellation Centaurus. It was literally the most populous concentration he had ever seen. But, technology at the time couldn't reveal its true nature, and his discovery kind of faded into the background. It wasn't until the 1980s that astronomers who were using new X-ray telescopes to hunt for the Great Attractor looked back at that region and saw intense, massive X-ray emissions. Finally, in 1989, researchers Somak Ray Chaudhary formally named this colossal structure the Shapley Supercluster, honoring Harlow Shapley's pioneering yet long-forgotten work. Section 2. Anatomy of a Giant. Sitting roughly 650 million light-years away from Earth, the sheer, mind-boggling scale of this giant is, well, it's honestly hard to fathom. 10 quadrillion solar masses. That is 10 million billion times the mass of our Sun. The Shapley Supercluster contains over 8,000 individual galaxies, making it the single most massive gravitationally bound structure we know of in the nearby universe. To put that kind of unbelievable scale into perspective, let's contrast it with our own neighborhood. The Virgo supercluster, which we are a part of, is vast for sure, but it essentially revolves around just one major galaxy cluster. The Shapley supercluster, on the other hand, it contains at least 25 major galaxy clusters, all packed tightly together in a comparable volume of space. It is an overdensity that is totally off the charts, packing an incredible amount of matter into a highly concentrated area. When we look at its physical properties, Shapley is a chaotic, incredibly dynamic environment extending roughly 200 to 260 million light years across. Because the gravity is so intense here, it's a highly active, unrelaxed system. I'm talking about entire massive galaxy clusters, specifically Abell 3556, 3558, and 3562, violently slamming into each other and merging at the core. In this dense environment, older elliptical and lenticular galaxies dominate. Their star-forming gas has been largely stripped away by the intense gravitational interactions and the incredibly hot ionized gas that fills the space between them, gas that shines brilliantly in X-rays. And right at the very heart of this cosmic pileup is the cluster Abell 3558, which is sometimes called Shapley 8. This right here is the central anchor of the whole supercluster, and it's one of the richest, most densely packed galaxy clusters known to astronomy. Sitting at the absolute center of Abell 3558 is a monster, a supergiant elliptical galaxy known as ESO 444-46, acting as the gravitational keystone for this entire chaotic merging region. Section 3. Gravity and Dark Matter. Now here's the kicker. All those galaxies and all that incredibly hot gas, they actually only account for a tiny fraction of Shapley's total mass. To understand how a structure this huge holds itself together, we have to look at the invisible forces at play. The vast majority of the Shapley supercluster isn't made of stars or gas at all. It's made of dark matter. By studying how the gravity of Shapley bends the light of galaxies behind it, a super cool process called weak gravitational lensing, astronomers can map this invisible mass. Dark matter acts as the cosmic glue holding these 25 or more clusters together. It's the sheer volume of this dark matter that creates the enormous gravitational potential well, responsible for those peculiar velocities we talked about earlier, including that mind-blowing 631 kilometer per second drag on our own Milky Way. Section 4. The universe's ultimate fate. Trying to understand a structure this impossibly massive isn't just about cataloging galaxies. It's about testing the fundamental rules of our universe. And the good news is, we are about to see Shapley like never before. A whole new generation of observatories is turning its sights on this giant. The Euclid Space Telescope is going to map its immense dark matter halos with unprecedented precision. The James Webb Space Telescope will zoom into the core to study how galaxies evolve and survive in such a violently dense environment. And down here on Earth, the Square Kilometer Array Radio Telescope will survey the faint radio emissions in the outskirts, tracing the cosmic filaments that feed matter directly into the supercluster. Which brings us to a pretty profound final thought. We know the universe is expanding, driven by the mysterious force of dark energy. But Shapley is so unbelievably massive that its own gravity is actively fighting that expansion, pulling itself together into a gravitationally bound unit. So the ultimate question for cosmologists is, who wins this eternal cosmic tug-of-war? Will Shapley's 10 quadrillion solar mass gravity keep it bound forever as a permanent monument in the cosmos? Or will the relentless accelerating push of dark energy eventually tear even this ultimate giant apart? The answer to that question might just hold the key to the ultimate fate of our entire universe. Thanks for joining me today, and keep looking up.